Hi, welcome back to NCRT class 10th chapter number 12 electricity. Children, so far we discussed about Ohm's law means what and how it is going to depend on certain factors we came to know. So dear children, with that previous knowledge, in today's class we are going to study about whether the flow of a current is same for different components or it will be different. We are going to know, children. It means that all different materials of a conductor which offers the same flow of a current through them, or certain components whether they will do what oppose, that we are going to study under this topic, children. Here this can be easily understand by making a simple setup, children. That is, we have to arrange the activity in the as shown in the figure, children. You have to take an ammeter, battery and a plug key, isn't it? You have to make a simple circuit, children, using what? Battery, ammeter and a plug key. And here I have used represented X and Y, means 2 points we have shown. Sorry, in the first case what we have to do means, at this point, means between these 2 points we have to connect the nichrome wire. Understanding, children, what we have to do? We have to connect between the 2 points X and Y nichrome wire, and we have to note down the what is the flow of a current in the ammeter. Means we have to note down the ammeter reading. After noting down the ammeter reading for the nichrome wire, we have to plug on the key, isn't it? We have to remove that and we have to replace the nichrome wire by torch bulb. At second step, what we are going to do, children? We are connecting, that is what, torch bulb here. And for the torch bulb also we have to note down the ammeter reading, isn't it? Means in each and every step we are adding a new component and measuring its current value, children. Means in the ammeter we are recording a certain values. Means here the torch bulb also gives a ammeter reading and it is noted, and we have to repeat the procedure by removing the torch bulb and placing what? 10 watts bulb. Here in the 10 watts bulb also we have to note down the ammeter reading. Means all these different components we have to connect one by one at these points, and we have to note down the ammeter reading. And after doing so, it has experimentally found that, children, the different materials like nichrome wire, torch bulb, 10 watts bulb is giving what? Different ammeter values. Means the current value for these 3 different materials is differ. It is clearly telling that the flow of a current is also going to differ for different materials, isn't it, children? The simple logic we have to understand here, children. If the ammeter reading of a nichrome wire is for example 0.5 amperes, just imagine, then torch bulb is giving what? 1 ampere. Means if such a difference we are getting when placing one material and another material, means it clearly tells us that the flow of a current is different for different materials, and certain materials will offer easy flow of a current, whereas certain different electronical components offer that is, they will oppose the resistor of a flow of a current. Means they will oppose the flow of a current through them. Got it, children? Certain materials offers easy path for the flow of current, whereas others will do opposition. Means they will resist the flow of a current, and because of that reason we are getting a different current values in the ammeter reading, children. Understanding my point, children? Yes. And moreover, we already learnt that motion of electrons, nothing but electric charges will constitute what, children? Electric current. isn't it, children? But these electrons, remember children, these electrons are not completely free to move in the conductor. It means that they are restrained by some of the factor, means they have retarded by the attraction of atoms which are present among them. So motion of an electrons are retarded by its resistance, children. Understanding, children? If the motion of electrons are retarded by its resistance, then because of this reason, different materials offer different value of current. Means certain materials allow easy path for the flow of a current, whereas others do resist. Means they will oppose the flow of current. Got it, children? Yes. So we can say that here, if a component of a particular, means on identical sites, then if it offers low resistance, if a conductor offers a low resistance, then it is called what? Good conductor. Isn't it, children? Suppose if any component or conductor, say any metallic wire, if it offers a low resistance, means then it can be called as a good conductor. Suppose if a conductor, if a component offers high resistance. Suppose if a component offers high resistance, then it is called poor conductor. Understanding, children? Poor conductor means it should have a high resistance, whereas good conductor means should have a low resistance. And indirectly, these poor conductors are also called as what? Insulators, children. Insulators. Do you remember, children, the general meaning of a conductors and insulator? Okay, no problem, I will repeat. Conductors are those substances which will allow easy path for the flow of current through them. Whereas insulators, they do not allow the flow of a current through them. Example for conductors, we can give metals like copper, aluminum, silver. These are all what? Good conductors. They will allow flow of electricity, means electric current through them easily. Whereas insulators, you take, children, rubber, isn't it? It's a poor conductor. Because of that reason, usually what happens, that is utensils are made with a what? Insulators. Means they do not allow flow of current through them. Even the switchboard, children, those are made with the plastic. Here plastic is also a type of a insulator. Got it, children? Okay, come back to the resistance topic, children. Yes, low resistance means good conductor. If a component offers high resistance means poor conductor, you have to understand. So in this activity, we can clearly understand that certain materials, means certain electrical components, offers easy path for the flow of a current, whereas others will do resist, means they will oppose the flow of a current. Because of that reason, we are getting what? Different emitter readings. And moreover, low resistance means good conductor, high resistance means poor conductor. Got it, children? And more here, identical some resistance is particularly called as a resistor, children, isn't it? Resistor. A resistor is a device which will be having a particular, means preferable resistance, preferable amount of resistance it contains, and it is called what here? Resistor. It is actually what? It's a device. A resistor is a device which will contains a one fine amount of resistance. Okay, is it the concepts are clear, children? Yes. At first what we did, we had made a simple setup using ammeter, battery and a plug key and a conducting wire. What we did first, we have placed the nichrome wire between these 2 points and we have recorded ammeter reading. And in the second case step, we have removed the nichrome wire, means replaced the nichrome wire with torch bulb, and again it's ammeter reading also recorded. And third step, we have replaced the torch bulb by 10 watts bulb, and here also ammeter reading is recorded. When we cross check all these ammeter readings of these three electrical materials, then it is what ammeter values are all different. By this we can conclude that certain materials offer easy path for the flow of current, whereas others do resist, means they'll oppose flow of a current through them because they are retarded by a resistance. Got it, children?